We have a series of equations here. There's 4 equations offered, and we're going to have to not solve them, but think about what the solution might look like. I don't want you to actually go through the math of solving this because we don't really have an equation for this. We have an approximation. We know it's quadratic, and if we worked at it a bunch, we could find the equation, but it's not necessary. I just want to talk about what the solutions are going to look like. I'll give you an example. Let's talk about this first one. When f of x equals 0, in other words, make a line at y equals 0. Remember, that's what f of x means. It really is talking about y. There's my line. The solution set, in other words, the intersection between the flat line and the parabola, is best described as, well, I can see it intersects right here. Okay, so how do we describe that? Using this list of options. Is it 2 distinct positive real solutions? Well, no, it's obviously negative. So it's not that one. Is it 1 real solution and 1 imaginary? No. 2 solutions both with imaginary parts? No, there's no imaginary stuff on this graph. 2 distinct negative real solutions. That's tempting. But if you look at the graph, I have a point right there, not 2 distinct points. Distinct means separate from each other. So barely fails that one. 1 positive real solution, 1 negative real solution. What that's describing is a situation like this, where you have 2 solutions on one on either side of the axis. That's not the case. So really the only possibility here is 2 real solutions that are not distinct. In other words, I have 2 solutions and they're sitting right on top of each other at the vertex. That's what the vertex of a parabola describes. Now, if we keep working through these, I think that's one of the more confusing cases. You imagine f of x equals 3. Okay, well, that's something like this. So f of x equals 3, what's the solution set? Well, there's an intersection point. There's an intersection point. So in this case, this is 2 distinct negative real solutions. Okay, there's 2 negative x values that mark the intersection points, and they're not at the same exact point. They're different from each other. Okay, so that's that one. Let's talk about the next one, when f of x equals -1. So f of x equals -1. I'm going to draw a line right here where y equals -1. Okay, what's the intersection between these two? Do you see anything? I don't. There's no real solutions here. So I don't have 2 positive real solutions. I don't have 1 real solution and 1 imaginary solution. I don't have 2 distinct negative real solutions. I don't have a positive real solution. I don't have 2 real solutions. Okay, so we crossed out everything. There are solutions to this, but they're imaginary. And it's hard to describe what imaginary solutions actually mean when we're looking at a graph that only has real coordinates on it. We can talk about what imaginary solutions mean if we're willing to talk about algebra. But in this case, you just have to understand that when 2 lines don't intersect on a graph, they may have imaginary solutions. And if we want to talk about the quadratic formula, then we can get into that, but I think that's beyond the scope of this problem. And then the final one, down here, when f of x equals 6, that's like a line like this. The solutions that for x is basically here and here. So you can see that's a negative solution and a positive solution, right? Here's the negative one. Here's the positive one. They're both real numbers. They might not be nice numbers. They might be crazy decimals, but you've got 1 real and one real positive and 1 real negative. So that's this idea right here.